Hi, I'm Lynn Turback, and this is the first in a series of screencasts that covers the material from CS111 Lecture 5 on Booleans and Conditionals. Before you begin, make sure that you have opened Canopy and that you have gone to the download folder in your CS111 server account and have downloaded the Lecture 5 programs, which is what I'm going to do from the CS111 account here. So CS111, download, and I'll drag over the Lecture 5 programs. Once you've done that, in Canopy, make sure you change your working directory to wherever you downloaded your Lecture 5 programs. And let's open up the file. Again, wherever you opened up your Lecture 5 programs, to lecture5code.py. And if you run that, you will have loaded in all of the definitions that we need for lecture. Finally, if you want to follow along, if you go to the schedule for February 9th and click on Booleans Conditionals, for instance, the 1-up version, you'll get the slides that we're about to go over. Almost every computer language has values known as true and false, which are so-called Boolean values, and they're named after 19th century mathematician George Boole, who defined an algebra on these values. And this is the basis for the logic that underlies digital computers. And true and false represent a choice between two options. They can also be known as yes and no, on or off, etc. In Python, the values are written with a capital letter. So in Canopy, if we want to write in the value true, it's capital T true, and the value false, capital F false. These are values of type Boolean. So if we find the type of true, we find that it's a bool. And if you happen to type one of these in with a lowercase value, you'll see that you get an error. Booleans arise naturally in the context of comparison or relational operators on numbers. For instance, if we ask, is 3 less than 5, that answer is true. But if we ask if 3 is less than 2, that answer is false. Is 3 greater than 2? That answer is true. Is 5 less than or equal to 1? That's false. Is 5 greater than or equal to 1? That's true. The two equal signs together test equality and are pronounced equals. For instance, this is the way to test, is 5 equal to 5? That answer is true. Is 5 equals 6? That answer is false. Note that we pronounce the two equal signs as equals, which is the reason that we pronounced the single equal sign as gets in assignment. So if we say, x gets 1, that is very different than asking if x is equal to 1. Finally, to test inequality, we use an exclamation point equal sign pronounced not equals. So if we ask, is 5 not equal to 6, that answer is true. It turns out that these relational operators can also be used to compare strings in dictionary order. So this is asking, does bat appear before cat in the dictionary? And the answer is true. Whereas, does bat appear before ant in the dictionary? That answer is false. Is bat the same string as bat? Yes. Those two strings are equal. Does bat come before bath in the dictionary? Yes, that's true. And now here's a really odd one. You might think that lowercase bat should come before uppercase cat in the dictionary. But in computer languages, all uppercase letters are considered to come before any lowercase letter. So lowercase bat, in fact, comes after uppercase cat in dictionary order in computer languages. So if we ask, does lowercase bat come before uppercase cat, the answer is actually false. Boolean values can be manipulated with the logical operators not, and or. The not operator inverts the meaning of a Boolean. So not of true is false, and not of false is true. For example, since 3 greater than 5 is false, the not of that is true. And since 3 equals 3 is true, the not of that is false. The AND operator takes two Boolean expressions and returns true if and only if both of the Boolean expressions evaluate to true. So for example, 3 less than 5, that's true, but bat does not appear before ant in the dictionary, so that's false. So since one of these values is false, the AND returns false. However, in this case, 3 less than 5 is true, and bat appears before cat in the dictionary, so since both of those are true, the answer is true. Finally, OR takes two Boolean expressions and returns true if one or both of those expressions evaluate to true. So for instance, here's a case where 3 is greater than 5 is false, but bat appears before cat in the dictionary, so since one of those is true, the answer is true. But in this example, this is false and this is false, so since both operands of the OR are false, the result is false. A somewhat unexpected feature of AND and OR is so-called short-circuit evaluation. And what this means is that if the result of the AND or OR operator is determined completely by the left operand, then the right operand is never evaluated. For example, consider a case where we have a left operand that involves a division by 0, which normally causes an error. In order to evaluate the meaning of this AND, we have to evaluate the left operator, which requires a division by 0, and so we get a 0 division error. However, if we swap the operands, and we have the case where we ask, is 2 greater than 3? Well, that's false. And we know that since AND requires two true operands, if its first operand is false, it can return false immediately without ever evaluating the 1 divided by 0. So this does not give rise to a 0 division error. Similarly, with OR, if the first operand evaluates to true, as in this case, we never actually evaluate the second operand, and so never notice that there's a division by 0 error. And this particular fact will be very important later when we write various predicates in Python. In Python, a function can return any sort of value that we like, so certainly can return a Boolean. In mathematics, functions that return Booleans are known as predicates, so we'll adopt that terminology here. Here are a few simple predicates in Python. For instance, here is an is-even predicate, that is, an is-even function that takes a number and returns a Boolean. And it determines if that number n is Boolean simply by taking its remainder relative to 2. If that remainder is 0, the answer is true, it's even, otherwise it's not. As a second example, is divisible by takes two numbers called num and factor and determines if num is divisible by factor, again by determining if the remainder of num relative to factor is 0. And our third simple example is same length that takes two strings named S1 and S2 and just returns if their lengths are the same. Let's now try these out in Canopy. We've already loaded them in before, so we can test is even, say, of 12. 12 is in fact even, but if we try 17, that returns false. And if we try our is divisible by example, let's see, is 36 divisible by 9? That answer is true, but 36 is not divisible by 8. And for same length, are the strings ant and cat the same length? Indeed they are, but are ant and bunny the same length? No, those have a different length. Here are a few more examples of predicates. Is between is a predicate that takes three numbers n, low, and high and determines if n is between low and high. The is Hogwarts house takes a string s and just determines if that string is one of the four names of the Harry Potter houses. And finally, is small prime takes a number n and determines if it's a number, an integer, that's between 0 and 100, that's prime. And this is rather complicated. So first it asks, is n an instance of type int? And then it determines if n is greater than 1 and less than 100, because the first prime is 2. And then we ask, is it one of the small primes, 2, 3, 5, or 7? And finally, is it not divisible by 2, 3, 5, or 7? And if it satisfies all of those many conditions, then in fact it's a small prime. So let's try out these examples as well in Canopy. So let's try is between. So for instance, is 7 between 5 and 9? The answer is yes. But for instance, 3 is not between 5 and 9. Is Hogwarts house is, say, Munger? Is that one of the Hogwarts houses? No, that's not true. But in fact, Slytherin is one of the Hogwarts houses. And finally, let's test some numbers to see if they're small primes. Is, for instance, 91 a prime? Turns out 91 is not a prime because it's divisible by 7. But we can ask, is 97 a prime? And that is, in fact, a small prime. Here's a very annoying syntactic detail about Python that you just have to know. If we look at our definition of is Hogwarts house, notice that we have the entire result as a parenthesized expression, and the same thing is true of is small prime. And you might want to know, are those parentheses actually necessary? In fact, they're not. But if you don't use the parentheses, you have to use something called a continuation character. So for instance, if is in Hogwarts house, we get rid of the parenthesis, it turns out that it's necessary to include this backslash here at the end of the line to say that we want to go on to the next line. And if we want to get rid of the outermost parenthesis in is small prime, we need these two continuation characters that are the backslashes. These are very annoying, and we recommend that in cases where you're returning any complex expression, that you in fact wrap it in parentheses so you can avoid these continuation characters. Okay, now it's time for you to go and define some predicates on your own. We ask you to define 3 predicates, and there's skeletons for all of these predicates inside of lecture 5.py that you should flesh out. The first predicate we ask you to define is freezing, which takes a temperature in Fahrenheit, and asks you to determine whether that temperature is freezing, i.e. less than or equal to 32 degrees Fahrenheit. The second predicate is long name, which takes a string and determine if that string has greater than 20 characters. For example, here's an example that is the name of a village in Wales that has a very long name. I don't know how to pronounce it. If you want to know how to pronounce it, go ask Reese. So that name is certainly long, but Wellesley is not a long name. And finally, there's a predicate is vowel that takes a string s and returns true in the case where that string is a single character that's a vowel, and otherwise returns false. So here's some examples, and for instance, capitalization shouldn't matter, so capital E and lowercase e should both return true, and any string that is longer than 2 characters should also return false. So go off, define these, and at the beginning of the next screencast, we'll talk about the solutions to these exercises.